Welcome to our second lesson in our Relations and Functions unit, and this is Lesson 2, the Introduction to Identifying Functions. So a function is a special relation, which we just talked about last lesson, in which each member of the domain, which are the x values, is paired with exactly one member of the range, which are the y values. So if you'll recall, a relation is just ordered pairs, a set of ordered pairs. So a function is special because it has to be, the x values have to all be paired with a y value, exactly one y value. So let's look at the different ways they sometimes represent this. And the first way is it says a mapping, which is what these are called, shows how the elements are paired in a relationship. And it says this first one is a function, this second relation is a function, but this relation is not. So I think it might be a little bit easier to notice what exactly the range and domain, the domain and range members are if we sketch a table. I'm going to ask you to just sketch a table, and we're going to put our x members, the domain members, and our y members. So if we look at the first relation, we have 1, and the arrow points to 4. So 1 is pointing to 4. If I look at 2, it's pointing to 3. When I go to 3, it's also pointing to 4. 4 is pointing to 5, and 5 is pointing to 6. So if we notice, all of the domain members are each unique, 1, 2, 3, 4, 5. However, if I look at the range members, I see 2 4s. So we have 4, 3, 4, 5, and 6. But yet it does say this relation is still a function. And that's important as we are going to explore this. And for my brain, it was easier for me to remember that if I saw the range members repeated, that was okay. But if I see domain members repeated, that's not okay. That's when it's not a function. And we'll see that coming up. So you can see that each one of these x values is matched up with just one y value. For instance, 1 is with 4 and 1 is not with any other number. 1 is not listed with 3. So the y values, the range values, can be repeated, but not the x values. So let's go ahead and sketch a table for relation number 2, which they're telling us is also a function. So 1 is matched up with 1. Negative 1 points also to 1. 0 points to negative 1. Negative 3 points to 6. And positive 3 also points to 6. So if I look at this, it might look like these x values are doubled, but they're not because they're opposite. So each of these x values, the domain values, are unique. But if I look at the y values, there's 2 range members that are the same, 1, they're both 1, and another pair that are both 6. So it's okay for the range members to be seen twice or 3 times repeated, or even repeated multiple times, but we cannot have the x values repeated. Each one of these x values should only have one y value matched up. So that brings us to the one that's not a function. So we're going to make a table, again, to compare them. And we're going to start with our first x value, and it's paired up with negative 2. And then I see another arrow from 1, and it's paired up with positive 2. 3 is paired up with 0. Negative 5, oh, it has 2 arrows, and it's paired up with 4, and negative 5 is also paired up with negative 4. So this is why this is not a function. Each x member can only have one y member. And so this x member 1 has two y members paired up with it. And what's going to happen is we're going to then see the x values more than once. And that's what helps me quickly identify. If I see a domain member doubled up, I see 2 1s and 2 negative 5s, even if it's just the one that was doubled. The y values are all unique. However, this is why this is not a function. It's because the domain members have been repeated. They're paired up with more than one. Okay, so I think it's a little bit easier to see this in a table, and now these tables are all completed for you. So I'd like you to take a moment and see if you can decide whether it's a function or not, and then start playing to reveal the answers. So pause the video. So for letter D, this is a function. And that's because no domain members are repeated. But officially, this is my personal way again to help. Officially, the x values only have one y value. And this is the official definition, the second one. So let's look at E. If I scan down, each one of the x members are unique. However, the range members are repeated. In fact, they're all 6. Yet this is considered a function. It is okay for the y members, or the range members, to be repeated. So let's write it. In case you're confused about that, again, 10 has one unique value of y, negative 5 has one unique. So each one of these, even though we see the 6 repeated, each one of the x just has one y member. And finally, the last one is not a function. And I, again, would say that domain members are repeated. However, the official way to say it would be that the x values, some x values, are paired with more than one. Y value. Okay, when you're done taking those notes, please move forward and turn to the next page. All right, sometimes they give us ordered pairs instead of a table or mapping. Sometimes they're represented just as pairs. So it says the relation, and it lists the ordered pair, represents a function. So they're telling us right off the bat that this is indeed a function. Okay, so I'm going to start looking at the domain members, and I'm noticing that none of them repeat, so that's helpful. If one was paired with, if I had a 1 here and it was paired with 1, and then this was also 1, but it was paired with 2, then it would not be a function. So this sentence says this relation represents a function because none of the y values, x values are paired with more than one y value. The next statement The relation, and again it's represented by a list of ordered pairs, does not represent a function because. So what do you think we're looking for? Well, we're looking at the x values again, the domain members, and as I highlight them, I'm noticing that I see 2 -3s. So this is not a function because one of the x values is paired with more than one number. Again, from my brain, I would probably think that one of the x values is repeated, but the official definition is x value cannot be paired with more than one y value. So now let's do my favorite, and most students' favorites, because it's probably the easiest because it's visual. On a graph, we could decide whether a relation is a function by using the vertical line test. And it says draw a series, meaning many of them, of vertical lines on the coordinate plane. If any vertical line crosses over more than one point on the graphed relation, then the relation is not a function. So let's look at what this looks like. If I dropped a vertical line, so vertical or up or down, if I dropped it and it hit my graph line, it only hits it in one spot, so that's good. If it's more than one point, then it's not a function. So each time I drop a vertical line, I'm starting over. So I'm going to drop another vertical line. It hit my graphs. There's just 1 point. Another vertical line, it hit it there, just 1 point. Each vertical line I'm drawing so far is just intersecting the graph line in one spot, okay? So even though you're seeing multiple vertical lines, what's key is that every vertical line I drop is just hitting the graphed line, or graphed relation in this case, in one spot. So this is a function. And if we look at the next one, this would happen again. Each one of my vertical lines is only going to hit in one spot on the graphed line. Each time I do that, it's just hitting the graphed relation in one spot. And so no matter how many of these I drop, I'm just going to be able to hit the graphed relation in one spot. So this is also a function. Now let's explore a couple that are not functions. So if I drop a vertical line, it's kind of hard to tell, but it looks like this might hit several spots, but that one's not very clear. So let's drop another vertical line that's much more clear. Yep, this hits my graphed figure relation in 2 spots. So if any vertical line touches in more than one spot, then we know this is not a function. And I could drop any vertical line. It didn't have to be there, but the minute I can find any vertical line that hits in 2 spots, in fact, we're going to be able to find several of them that hit in 2 spots, but the minute you use one that hits the graph figure in 2 spots, it's not a function. This next one might be a little bit trickier. If I drop a vertical line, well, it only hit it there. And if I keep on doing vertical lines on this side, it's only going to hit it in one spot, each vertical line. However, when I move over here, it's going to hit it in that spot where the point was, and it's going to hit it again here. So I can find a vertical line that hits in more than one spot. In fact, from here I could draw another one in between and hit in 2 spots. So this one vertical line alone is enough to say it's not a function. However, in this case, we could find a few more. So thanks for listening, and have a good afternoon. Take care.